This is effective Docker and Kubernetes for Java EE developers. What is this session about? The motivation for this session is actually to show Java EE developers what their specific concerns are in running their applications in Docker and Kubernetes-based container environments. So we won't be covering a whole lot of basic things per se, but what we'll be showing you is various trade-offs of how to use these kind of things and how to get the most out of it. It will be extremely fast-paced. In fact, beyond this one slide, we won't have very many slides. All really we'll be doing is demoing one thing after the other and showing you what's behind the demo and what are the kind of trade-offs that you need to be thinking about while using Docker and Kubernetes in Java EE developers. The good news here, though, is beyond getting a taste of things and getting a high-level view of things, we put the materials for the entire presentation on GitHub. Okay, so if you look at the GitHub URL, it has step-by-step instructions of executing exactly the demos that we'll be showing you here today. Okay, in fact, to be honest with you, we will be skipping to minor portions of the demo just because we don't really have time. You can go and look at these yourself. And also, one of the things that I will tell you right away is that right after this session, you can come and talk to us at the IBM booth. Okay, downstairs. We will be there. We can show you more demos. We can show the code in more detail. We can talk about any particular topic in more detail. Okay, so without further ado, let me briefly introduce myself and my co-speakers here as well. My name is Reza Rahman. I'm a senior vice president at AxonIQ, and I have two of my very good friends here. I'm very proud to have their help in this session. Please introduce yourselves, gentlemen.
Yes, it's me, Ahmad Gohar. I'm working as software architect and senior tech lead for IBM.
I'm Hillmer Chona. I am MedellinJUG Java user group leader, co-organizer of the Comunidad Hispana de Grupos de Usuarios, and I work for the University Catholic Luis Amigó in Medellin, Colombia.
Okay, so Ahmad, Hillmer will actually get us started here today. So what Hillmer is going to show you is a basic Java EE application run in the sort of old-fangled, old way of doing things without Docker and Kubernetes. And actually, this is the same application that we will be redeploying again and again to show you different aspects and different trade-offs of using Docker and Kubernetes. So please, Hillmer, take it away.
This is a Java Enterprise Edition application that uses Postgres database. For this case, we are going to run Postgres on Docker. It doesn't matter where the database is. Let me, I run first the database. Okay. And the application was created with Maven structure. Let's go to install package. And we are going to use Welfare Liberty as application server to run the application. This is the application. The application has a Java Server Faces client that can be used to consume the RESTful service. I'm going to create coffee, Colombia coffee, score. Where is the country icon? And let's take a look about the code. To talk about the technology that we are using in this application. We use JPA for an entity. It's only on one entity. We use Java Enterprise Beam. And we use Java Server Faces for the client, and Beam validation is another Java Enterprise technologies. Let's see how to access to the RESTful service. This is the RESTful. In order to allow Welfare Liberty to run this application, we need to add the Postgres file. Is the database that we use. The only thing that we need to do in Welfare is add the future Java Enterprise Edition 8. With this line, every technology, we can use the whole technology that comes with Java Enterprise Edition 8. The second thing that we need to do is create the data source to connect to the database. As I say, it doesn't matter where the database is Docker, is standalone, or is another server. And add the library for Postgres JDBC. Okay, let's go to the next.
Okay, so what Hillmer just showed you is nothing new to you, right? So now it's a question of going to be taking this WAR file that was just generated by the Maven build and putting it inside of Docker and running it inside of Docker. So what we'll be doing is showing you various trade-offs of doing these things. And in the home page, you'll see what is it that we're going to go through. So we're going to go through 3 different techniques of packaging Java EE applications. One is a thin WAR approach. It's the most common approach that Hillmer is going to show. And then Ahmad is going to show you 2 different interesting alternatives that is also worth thinking about, namely Uber jars and hollow Uber jars. We're going to skip over the export and external volume sections. Again, if you want to take a look at these, you can come to the IBM booth and we'll show you what these are about. This is also something you need to know about while using Java EE with Docker and Kubernetes. And then finally, I'm going to hopefully get enough time to show you a little bit about how to take all of this stuff that we'll be talking about with Docker and making it work with the cloud and Kubernetes. So with that, I'll give it back to Hillmer here.
Thanks, Reza. Now I'm going to show how to deploy our application in a Docker container. In this link, in this case, we have the server XML file. It's the same. We haven't changed anything. And we need the Postgres jar, and we need in order to create the Docker file, the Docker image, we need to copy the WAR file. I copy. Is there? I have the WAR file here. And let me first stop the server because we are going to use the same port. We don't want to get a port problem. Here we have the Docker file, the WAR file, the Postgres jar, and the server XML. Let's go to destruction. It's the same database that is running in this moment. Let's go to build a new Docker image. Meanwhile, let's look the Docker file. The image that we are building comes from Web for Liberty that is taken from the Docker Hub. And we copy the Postgres jar file into the resource share directory, then copy the server XML, and finally we add our WAR file to make the application inside the image. It's finished. Let's go to run the application with Docker run command. Okay. In this part, I'm going to talk about the port. We need to export the port 9080. That is the port that we want to access the application from outside the Docker container. The server is running. Let's go again to okay. As you can see, the application is the same. We had the data that Aaron created some minutes ago. It is because we are going to run the database with an external volume. That this technique allows us to maintain the information of the data that are stored from the application or from outside the Docker container. Now, Ahmad is going to talk about.
Hillmer, show the caching and layering.
Okay, yes. Let's go. Let's go to try to reveal a new image to show something interesting. As you can see in this time, the process was faster than the first time, and it's because in this Docker build process, Docker process state for cache some component. How can it be possible? It's because the order that we create our Docker file. That means that the order that we set this element is important. In this case, in this example, anything change, they take everything for the cache. That makes the process faster. It's probably in our application or our Docker image, the only thing that we change is the image. So in this case, it's probably the Westfair Liberty doesn't change a lot, the PostgreSQL file doesn't change, and at the same with the server XML. In this case, we put at the last place the WAR file that is supposed to be changed when we need to make some changes in the application. Now, Ahmad is going to show us two different ways that we can deploy our application.
Okay, so Ahmad will hopefully show you this, but basically what happens is each line in the Docker file actually generates a layer that is actually cached by itself. So if we had rebuilt the WAR file, even for this thin WAR image, the next time we build the image, what will happen is all of the parts that were before it, all the way up to the copy of the WAR, is already going to be cached. So it's really just the regeneration of the new WAR file being put into the image. That's all that would be required. And this is not just locally. So when you're going to push this image up to the Docker hub and then pull it back from Kubernetes, in all these cases, the same caching will still be in effect. So really, all you'll be moving around is just the thin WAR. So that's why it's called the thin WAR section. Maybe, Ahmad, if you have some time, if you can show that in action, just changing the WAR file.
Yeah, perfect, okay. So if I need to make some change here, like I can open any resource. Make any change. Okay, and I'll install new one. So now I have an updated jar. Then I'll start to build a new image.
You need to copy the WAR file.
Yes, sorry. That's the updated jar file, WAR file. I replace it with a new one. Then I'll start build new Docker image with a new version. Now, as you see that the first layer had been came from cache, and the only one that had been updated, it is the fourth layer, which contain only the WAR file. So for every and each update we have, we will use the cache from the first three layer, but from the fourth layer, we will have our newly updated WAR file. And now I'll start explaining a new technique that's called Uber jar or fat jar.
a new, fresh copy of the application, because there's some changes that are in the POM that are necessary for this, which Ahmad is going to go through. The POM is really where all the heavy lifting is going on in terms of generating the workshop.
I'll start. Now it's my, that's the location of the new project that's contained the updated codes that Reza mentioned, and we will show you what is the updates of the code. I'll start with a simple Maven clean and build command. What? Okay.
Install.
So actually, let's see what's been done now. That's our BOM file. The BOM file, it's start with normal BOM file, and I want to show you two main differences here in that BOM file. The first one, that we have a plugin, which is a Liberty Maven plugin. That plugin allow us to include the WebSphere Liberty runtime profile and downloading it from the internet using our specified version, which is 18.03. And thanks, Reza. And we use the WebSphere Liberty profile GEE version 8. And we need to export jar file, which name is Java EE Cafe, and it's a runnable jar, and it will include all the dependencies we need. And how can we include all the files that we need? The first, we are starting to elaborate more in the execution phases. So we start when the install application, we request from the Maven to copy the server.xml file, which contains the data source and our application configuration to the zipped WebSphere Liberty profile. Also, we have here another Maven plugin, which is a Maven dependency plugin, which we use to include the Postgres database JDBC driver. And now we have our WAR file have been created, and also our jar file have been created. So, and that's our that's WAR file. So it's our thing, the Uber one, JEE Cafe, and that's the jar file, the the jar file. So now I'll start building my Docker image using the same command. And let's have a look over the Docker image file, Docker file. The Docker file, its base layer, it's OpenJDK. We don't need Liberty anymore because we are including the Liberty profile inside our jar. So we start with the OpenJDK. We change the directory to the root, then we copy the generated jar file, then we expose the port 8090. And the last line, it was running the jar file like our normal day-to-day activity, java-jar, and the name of the jar file. And it's successfully built. Then we will run our Docker image. The running of our Docker image here, it starts when we go to the line of the java-jar and the jar file, that we will start to extract our jar file to build our runtime environment. Then it will start to copy the application server configuration file, which is server.xml, and downloading and installing the Postgres driver. And it's include and install all the features that we need in the application server. And we can see the application, it's up and running using our shared database. Okay. Another option I want to show you here, it's hollow Uber jar. Let me close that. Okay, now I will not build the application. I'll use the same application for time saving. I'll start with building the Docker image. And here let's see a couple of features that, a couple of files that I want to show you that. The first one, it's the Docker file. Here we start with the libsphere kernel, and then we start building layer by layer the needed component of the WebSphere library. So we'll start with JSF and all those features. After we install all those features, we will copy the Postgres driver and the configuration file. Then we will copy the WAR file. Okay, and I want to show you also the server.xml file. The server.xml file here, it includes the needed feature only, not what like what we did before, which is the Java.io hollow feature. We include the specific feature needed, and that is the difference for our POM or server.xml file. And during our building of the image, let me show you what is the trade of the three solutions that we show you that. We started with the first thin war that Hillmer shows us. What is the pros and cons of every and each one? The thin war, it's small size. It's contain only the source code. We don't have any thing from runtime or the libraries that we need. But the drawback of it's the size of the Docker image is higher than the normal one. Then the self-contained jar or the Uber jar, the pros of it, it's contain, we name it, it's all-in-one because our jar, it contains application servers, the source code, the dependency, and all what we need. And it's very good in the environment that the production environment is unstable or uncertain. But the drawbacks of that, as you remember, the Docker file, it's contain a little layers, and when we start to update any line of source code, we need to update the jar file, which somehow builds the entire Docker image. We are leaving only, we cache only the OpenJDK layer. So the hollow Uber jar, it is recommended in the non-Dockerized environment or the environment that the production environment is not stable. The hollow Uber jar, it's we install every and each component we need by ourselves. So it's minimize the size of the it's minimize the footprint, memory footprint. We install only the feature that we need, and it's running, it's faster. But the drawbacks of that, as you see that it is the longest time we took for building the Docker image, but after the first run, we will use the cached features, the caching feature and the layering from the Docker, and we will update only the last one.
Why did you show it, Ahmad?
Yeah, sure. So if I build it again, it's just a second. Did you catch it? Okay. So let me start the application. Run the Docker image first. Give it a couple of seconds to run. We should see the same application now. That's it. Thank you. Reza.
All right. Excellent. Give me a few seconds here just to get myself started. I'm going to shut down these browser windows, clear the console, go back up one. Where am I? Okay, excellent. And I'm going to cheat a little bit while we're talking here. And show you the Kubernetes console. Okay, so what we've done here so far is build the unit images, right? So we have an image for the database, we have an image for the actual application runtime, however that happens to be packaged. But then at the end of the day, each time you need to run these packages, you need to actually execute the run command, which is fine. If you just have one or two instances of these things, it's not a big deal. But in reality, that's not going to be what's going to happen in a cloud-based environment or in most production environments. So in that cases, you will have tens or maybe hundreds of instances of all of these containers. So you don't want to repeat yourself, right? Run a whole bunch of run commands or write hundreds of long lines of script. So what is the solution there? What is the solution to that problem? In addition to the other problems like, okay, how do you provision all of these containers? How do you scale them up and down? How do you get network services? How do you get commodity things like load balancers and the like, right? So Docker by itself, it's a nice technology. It allows you some level of power, but it doesn't answer a lot of these other questions. So what is the answer there? And the answer is Kubernetes. So obviously we're not going to have a lot of time to dig deep into Kubernetes, but I'll show you Kubernetes in action and show you a little bit about how these Java EE applications will run in a cloud-based Kubernetes environment and take a look at least the basics of how that looks like. So over here, I'm using the Google cloud as my example. It doesn't really matter. You can use any cloud that will support Kubernetes, and pretty much all of them do these days. So this is the KDE console, or rather GKE console. It's one of the better consoles out there. Just to go through the console here, I have created a cluster. So this is the, if you will, the data center that I'm going to be deploying my application to. I do not have any workloads. I do not have any services defined. I do not have any storage defined at this moment. And I do not have any configurations defined. Don't worry about what these things mean right now. I'll take you through what precisely these things mean in a second. But basically, the main takeaway here is that we're starting from a blank slate. So let's go ahead and create a production-like environment now based on the Docker images that we created earlier. As an example, as a starting point, I'm going to use a thin var technique. It's the easiest to use technique, but in the end, it doesn't actually matter. Any particular Docker image will work exactly the same way, however you choose to package it in the end. So let's go ahead and do the first step. So if you remember, our first step outside of Docker was to create our Postgres database. So we're going to do the Kubernetes version of that exact thing, but we're going to do it through a script of sorts. And I'll tell you in a second what the script does, but I'm going to go ahead and execute the script first. So here's my first script, and I'm going to just paste this guy in. Can everybody see this text, by the way, or do I need to increase the font size a little bit? No? That's okay. All right, so let's go ahead and execute this. And what this is doing is these YAML files are effectively scripts. It's telling Kubernetes exactly what it is that it needs to be doing. So let's wait here for a second for Kubernetes to do its thing, and let's see what happens. So as you can see from the output, you know what? I'm not convinced that you guys can actually see the screen. So I'm going to increase it just a little bit. So what is happening here is several different steps. One is that we have created a configuration map. So there's some variables that we need to use throughout our Kubernetes data center, and that's what we're going to expose. I'll show you in a second what those values are. Next, we've created a persistent volume, right? So this is a database. It's a stateful application. It needs to store. It needs some kind of persistent file storage. And what this persistent volume technique is doing is that it is allocating some space on my Kubernetes cluster. Next, I'm creating what is called a deployment. And a deployment is really nothing much more than, okay, how are these machines going to look like? Each of these machines that I will spin up using Docker Kubernetes, what is the template for that, right? What is the profile of it? And finally, we have to create a service. So just creating an instance of a machine in a Kubernetes environment will not work on its own. In order for those machines to be usable in some shape or fashion, what you need is a so-called service, okay? So let's now take a look at the end result of my executing all of these commands. So let's now go ahead and look at the state of my cluster. So again, there's my cluster sitting over there. Next, I'm going to show you the storage tab. So what you see now is this is no longer empty, okay? So I have a little bit of storage that was created as a result of my executing my YAML file. And I've also created some configurations. And remember, these are values that I want to take a look at throughout my environment. So I'll show you what is actually in here. So what I have here is just 2 separate values. And again, I'm not convinced you can actually see the screen. So I'm going to increase the font size just a little bit. So what I've stored here is the stuff in the very bottom. Okay, so I want to know for my Java EE app, what is precisely the username and password that I should be using for my Postgres database. I need that information in the server.xml file in particular. And finally, if I go back a second here, and what happened, I need to, I guess, minimize things a bit, okay? Then what I have is a workload. Okay, so a workload is literally the machine that I'm spinning up in the Kubernetes environment. Okay, so in this case, I just need one instance of Postgres. All right, so I have one running instance of Postgres. That's what the pod means. One means I've defined one machine and it is now up and running. Finally, I have services defined. Okay, so in my services, the service type I have chosen for my database is called cluster IP. And what this is doing is that it is taking that single machine instance and making its IP available throughout the cluster. And I need that obviously because my WebSphere instances need access to this IP address, and hence I need to know what this IP address actually is. Now the question then becomes, okay, so how do I know? How do I know what that IP address is? Well, you can get that programmatically. And what you can do is you can get the programmatically what that service endpoint is attached to Postgres and store it in a configuration file. Okay, I'll show you that in an action. So let me copy this guy over and paste it here. Okay, so what I'm doing here is I'm telling Kubernetes, please get this service. It's called Postgres. Give me the JSON path, and I'm after the cluster IP address. And then once you get that, please store it in a different configuration map that I'm going to call hostname.config, and the value I want to store it in is called Postgres host. Okay, so let's run this command. And it's relatively fast. It's just creating an environment variable for me. So now let's go back to my console and see what the end result here was. Okay, so the end result here was that I've now created a hostname config. Right, so if I click on my hostname config, there is only one value here. Let's see if I can show you what this is. And that's the Postgres host at the very bottom of the screen, and that is the internal IP of it. Okay, so anybody within the Kubernetes cluster can now access that Postgres database using the username and password as well as the host name. I'm sorry, I very much doubt we will have time for questions. But please come to the IBM booth afterward, and we'll be there literally as we walk out the door. Okay, so there's the IP address there, and now we're almost ready, right? So what we're ready to do now is actually create our WebSphere instances, right? So in order to do that, the first thing I need to do is actually create the Docker image. So I'm going to use, again, just a thin wire approach. It's not very, very different than what we had been doing. There's a subtle difference, which I'll talk about in just a second. Okay, so the subtle difference here is that notice I'm being a little bit more fancy in how I name my image, right? So what I'm trying to do here is actually say, please build this image, and this image will ultimately wind up in Docker Hub under a username called Reza Rahman, and I'm versioning it as well. So I'm giving it a version number v1. Okay, it could be anything that you so wish. So where is this going to wind up in the end? Where this is going to wind up in the end is actually in Docker Hub, which we seem to have lost, and I will just bring up in a second. Okay, so this is my Docker Hub account. And you'll notice there's nothing here. Okay, nothing here at the moment. So I'm going to go ahead and build my properly versioned and tagged Docker image. So here we go. And as you can see from the output, it's just using this thin var technique. So just taking WebSphere liberty, copying the Postgres in the server.xml, and then finally copying over the var file. So this image is now built locally. Okay, so now what I'm going to do is I'm going to push this image onto Docker Hub. Well, why do I need to do that? The reason we need to do that is because we're on the web, right? We're on the cloud. The Google Cloud has no way of accessing my local machine. What can it access? It can access Docker Hub. So hence, I need to push this image up to Docker Hub at this point. So I'm going to do that next with this command. and that is simply Docker push, and you'll see that in a second when I copy it into the console, I hope. Okay, so there it is. It's relatively simple, just Docker push and the fully qualified name of the image that I just created. So we're going to go ahead and hit enter on this. And it's doing a push, okay? And remember, over here, all of that Docker layering and caching stuff that we were doing, all of that stuff comes into effect, okay? So the next time I want to build just a WAR file using the thin WAR technique, all of this stuff won't happen. All that will happen is just the WAR file will be pushed because everything would have been cached on the server side, okay? And similarly, the same thing is going to happen when Kubernetes tries to pull this image from Docker Hub as well. So now we're all set. Show you the end result of the execution of my push command. I'll refresh my screen here. And because we are on the web, everything is a little bit slow. Okay. Give me a second here. I hope we haven't broken something. Okay, let me take a look at the, no, it should be up there now. It's just extremely slow. Come on now. Let me try the push one more time. Pardon? Push harder, yeah. Let's see. Okay, let's try this one more time. Layer already exists, so it's cached. So it's there, it's just not showing up on my console. Let's hope maybe I can force it to do something here. Come on. Okay, here we go, finally. Okay, so it's up there now. Okay, it's in Docker Hub. It's ready to be pulled by Kubernetes. Okay, so let's go ahead and do that next. So what I'm going to do now is actually run another script called Java EE Cafe, and that will take that Docker image, okay, that I just pushed, and it will create my machines for me. Okay, and guess what? It's going to create actually 2 instances this time, whereas in the Postgres instance, it was just 1 image. So let me go ahead and execute that. Okay, and this is relatively simple, okay, because I'm not doing a whole bunch of fancy stuff. All that I'm doing here is creating the deployment and then creating the service behind it, okay? So let me show you the YAML file behind this one. So if we go to my GitHub repo, and down below we have this. Apologize. This is what happens when you have a bunch of demos. You kind of have to shuffle back and forth. Okay, so this is what is actually in the Java EE YAML file, okay? So this is the definition of the deployment in this case. Okay, so I'm defining how my machine looks like. It is pulling from the image from my Docker Hub account in the Reza Rahman. I actually have it properly modified in my local environment, but it's pulling from Docker Hub. And then what it is doing is that it is creating 2 instances. Notice this replica equals 2. Okay, so it is taking the Docker image and actually creating 2 running instances of WebLogic with my application deployed. And I have several environment variables that I'm defining here. So all of them. So Postgres user, Postgres password, and Postgres host. Okay. If we have a second, and or you can come to the IBM booth, I'll show you how these values are actually being pulled in the Docker and referenced in the Docker image. Okay. So the Docker image knows how to pull these environment variables, and that's why we're defining them here. And then finally, this is another interesting thing. Notice the type of service that I'm defining here. Okay, so the type of service in this case is not cluster IP because I have two instances. What I actually want is a load balancer. Okay, so I want a automatically created HTTP load balancer that knows about those 2 nodes that I just created and is going to actually randomly load balance between them. And this load balancer will actually have an external IP that I can access on the internet. I'll show you that in a second. So hopefully by now the results of our execution is already done. So let's take a look at what our cluster looks like at the moment. Okay, so looking at the storage, and yet again, slow network. Okay, there's our volume. Our volume is still there. I didn't do anything to it. Here's the configuration. And the configuration hasn't changed either. I haven't added any new configurations. However, what I have added is that I have added a deployment of 2 pods. Okay, so if I click in within these, I'll actually see that there are 2 pods created. Okay, so these are specifically the neighbor of my pods, and you'll also notice that this is exposed by a load balancer, and we'll see the load balancer in a second. I'll show you the load balancer as well. Okay, and you can also actually monitor if this ever shows up. This will actually show you, the workloads part will actually show you what is going on with your server actually. Maybe we'll revisit this once we access the machines a few times, and hopefully some interesting stuff will show up here. So over here, I have my service. Notice a new service was created, just like a new pod was created. A new service was created, and that is of a load balancer. And also notice that it has a endpoint. Okay, endpoint URL that I can access externally. So all of the internal IPs start with 10.31 inside of the Kubernetes. But that one, the load balancer, actually has an external IP that I can access from the outside. So I'll go ahead and do that. So lo and behold, we've hit one of our instances, okay, from the network here all the way to Google's cloud, and I haven't run a single Docker command, right? It's literally, if you count, I've executed 2 commands really, 2 different YAML files that I've executed, and I have an entire running data center in the span of a few minutes, about 10 minutes, I would say, and that's it. It's really that magical. So I'll go ahead and show you the application. Hopefully, the application has deployed by now. It's not yet loaded. Okay, we'll just give it a few seconds to load here. In the meanwhile, could I show you something interesting? Not yet. I will show you what these things do, but I want to get the application up and running first. So let's see. Let's give it a few more times. So this network is exceptionally and annoyingly slow.
Java EE.
Oh, sorry. This time I'm being slow, not the network. Okay, so here's my application. Obviously, the database, we haven't done anything with it yet, right? So we could enter some values here, and it would work the same way, right? We'd have an external volume that's shared across the cluster. Even if I restarted the whole cluster, that data is still going to remain there. Okay, so what are the primary takeaways? Oh, I haven't showed you one more interesting thing here. So I'm going to, remember there are 2 instances of WebSphere running, right? I'm going to add a 3rd instance, okay? And I can simply do that by typing incorrectly, by executing this command, okay? So what this is doing is that it is saying, please take that Java EE Cafe deployment and increase the number of replicas to 3. Okay, I'm executing it right now. And it'll take just a second, and it says it is scaled. So let's take a look at the end result. Okay, so let's go back to my Kubernetes console. I want to close some of this stuff. Now, going back to my Kubernetes console, you'll now notice that I have 3 instances, okay? So Kubernetes has auto-deployed, has taken the image and auto-deployed another instance, okay? And I did absolutely nothing there other than execute that one single command. Imagine doing that a few years ago, right? I can similarly also scale down. So I'll show you the scaling down portion. I can say replicas is equal to 1. And execute that. The cluster is scaled up. Let me refresh this page. And now you have just 1 running instance out of 3. Actually, it's not done spinning down yet. It'll slowly spin it down, but ultimately there will be just 1 pod of 1. Yep, there's a 1 pod of 1. So I've spun down the instances. Okay, so what's the primary takeaways here? The primary takeaways here is that you have choices to build the Docker images in whatever way you feel is most efficient. And then Kubernetes is actually doing a lot of the heavy lifting for you. So imagine all of the things that Kubernetes has already done for you that you would needed to have done if you are in a traditional app server environment. So we have created a cluster of servers without any real effort. We didn't do any app server configuration whatsoever. We didn't configure the HTTP load balancer at all. It's just configuring it, and it knows about the clustering features in there. Let me maybe show you some of the health statistics that I hope shows up finally. So let's go to the workloads. And if I go to Java EE Cafe, hopefully there's some data that eventually shows up here. But this is equivalent of what you would do to these days with, or in the old days with the application server consoles, right? So it'll do the cluster start, stop, redeployment for you. It will do basic health monitoring for you. By the way, if I pushed another image with just the WAR file, this entire cluster would actually be restarted on its own now, because it knows to look at my Docker Hub location for deployment updates. And again, it will just take the deltas more than anything else. Okay, thank you very much. That is all the time that we have. I hope you enjoyed it, and please come and visit us at the IBM booth, and we'll show you much more.